Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are on this paper which is S2 paper 6 of FEB March 2026. Let's get started. So let's read the first question. It says, let me highlight it. The heights at centimeter of a random sample of 8 one-year-old plants of a certain variety were measured with the following result. So 1, 2, 3, 4, 5, 6, 7, 8. That's the 8 pieces of info. Calculate unbiased estimates of population mean and variance. Unbiased estimate of population mean, we use the symbol that is equals to sample mean. Unbiased estimate of population variance, it's n over n minus 1 sample variance. The formula for x bar, that is sigma x over n. The formula for sample variance, that is sigma x square over n minus x bar square. Now sigma x, it means sum of x, and sigma x square, it means sum of squares of x. That's the first thing. Then it says it's now given that the true value of the population variance is 85, stating a necessary assumption. Find 99% confidence interval for the population mean, given that the limits of the interval correct to 1 dp, therefore work in 2 dp. Now just have a look. Does it say it follows normal distribution? No, it does not say. So most likely the necessary assumption is about CLT. Let's go to the next page. So this is the unbiased estimate. That is x bar sigma x over n. Add these 8 values. Show the working. Add it up. The sum divided by 8. That's an exact value. Unbiased estimate of population mean is the same thing as sample mean. That's the formula. Square each value, add it up. Don't forget to subtract mean square. I have shown this value. I have shown even this value. The calculator is giving me an answer in the exact form. Multiply with n over n minus 1. That's the exact value. That is the 3SF value. Now stating a necessary assumption. Now how come all of a sudden we see a z value over there? That means normal approx is used. So now over here, normal approximation means sample size is large. Therefore, CLT applies. That is the concept that's used over here. Now over here, this is half percent. This is half percent because this is 99% symmetric confidence interval. 99.5, the z value is this thing. We have x bar, we have n, we have z, we have sigma square, we have sigma as root 85. X bar plus minus z sigma over root n. First of all, write everything down. Then show this working. So let me highlight this, show this working, and that is this much. And once we will add, once we will subtract, these are the unrounded value and the final rounded value correct to 1 dp. That thing is done. Question number 2. Let's read it. Now this question says last year, the time and minutes spent by customers in a certain shop had a mean this and standard deviation this. This year, the shop owner wants to test whether the mean time spent by customers has changed. That means it's a two-tail test. He decides to choose a sample of 20 customers. A shop assistant suggests that they should choose the first 20 customers. Maybe the assistant is lazy. So he wants to get rid of the thing, but that won't give you an unbiased sample. That won't give you a random sample. Give 2 reasons why this will not produce a random sample. What are the 2 reasons? We will soon see. The shop owner decides to carry out the test at the 10% significance level. It's the same 20 customers. The mean time, the sample mean is 8.4. You should assume that this follows normal distribution. State an assumption that is necessary. Now, a lot of people, they think that normal distribution was the assumption. That was there because of CLT. What assumption is there? That we are using the same standard deviation as before. It's not changed. Carry out the test. First of all, decide and write down what kind of distribution does it follow. Then H0, H1, then calculate the z value, then the normal distribution curve, and then reject or accept null hypothesis and write down in your own words. So now let's have a look. First of all, why this is a biased sample? Every day of the week is not considered. There should be a clear distinction between weekday versus weekend. Of course, in the morning time, very low chances that customers will come. They will usually come in the morning time on weekend. only morning slot is considered. What about the afternoon slot? What about the evening slot? So these were ignored. That's why it's a biased sample. What is the assumption? Population standard deviation or population variance is unchanged. That is x bar follows a normal distribution such and such. That is the sample mean. So that is the first piece of info. So that you need. The second piece of info is that H0, H1 and the significance level. That's the second one. The third piece of info is that calculation of the z value, x bar minus mu sigma square over n, the whole thing under root. And the fourth thing, that is this one, which is the z table and these values and the critical region and all these things. And then what do you have to look for? I just want to get this line drawn properly. So now this causes a trouble. Now this is all done. So now what it says is this thing, that the z calculated value, it lies outside of the critical region. It was a two-tail test. So let me write over here, this is a two-tail test. So that means the 10% is divided equally, 5% on the right, 5% on the left. Z value is this for 95%, and similarly the symmetric value over here. The calculated z value lies outside of critical region, rejection region. Do not reject H0, accept H0. Insufficient evidence at 10% significance level to accept that the mean time has changed. The mean time has not changed. There is no evidence for that at this percentage, at this significance level. So that is the thing that you have to write. Question number 3. A shop sells two types of cell phone. Sales of the two type occur at constant average rate. The first one is 3.2 per week. So the first one is 3.2 per week and the other one is 2.9 per week. You may assume that the sales occur at random and independently. Now these are the conditions for Poisson. It occurs at a constant rate, it occurs at random, it occurs singly, it occurs independently. Now 1 week is chosen. That means this 3.2 and this 2.9 won't change. Find the probability the shop sells a total of 5 cell phones. That means both the means will be added. And then you have to calculate. Find the probability the shop sells exactly 5 phones of one type and none of the other type. Nice question. We'll just show you the working. So now over here, X follows a Poisson distribution. That's the first type. The other one follows a Poisson distribution, 2.9. 3.2 plus 2.9, that is 6.1. It still follows a Poisson distribution. Exactly 5 phones, e raised to power of negative 6.1, 6.1 raised to power of 5 over 5 factorial. That is the unrounded value and this is the rounded value. Now this one was a nice question. Find the probability that the shop sells exactly 5 phones of one type and none of the other. That means it could be 5 of X. So it could be 5 of X or it could be 0 of Y or it could be 5 of Y and 0 of X. So now both these options are there. So either this thing is there. Now I have done the calculation on the above thing and then I have written it like this. So therefore this is like this. Either this option or this option. So now there is X is 5, Y is 0 or Y is 5, X is 0. The calculation is there at the top. So now look how wisely I have played out my working. Now look at how I involve indices. Now first of all, I have this value which is e raised to power of negative 3.2. I have e raised to power of 2.9, e raised to power of 3.2, e raised to power of 2.9. So negative 3.2 plus negative 2.9 and there is a negative sign over here. That adds up. So now this is e raised to power of 6.1. So now I have taken this and this common out. What am I left with? I'm left with this is 3.2 power 5. This is all multiplying, divide by 5 factorial. 3.2 power 5 over 5 factorial. Over here, what am I left with? I'm left with 2.9 power 5 over 5 factorial. And there is an addition sign over here. This is or, that addition sign goes over there. So now I have taken this thing common. This is 3.2 power 5 over 5 factorial, 2.9 power 5 over 5 factorial. And then I work this out, and that is the final answer. So a very, very nice question of Poisson. Question number 3. Then it says use a suitable approximating distribution. Now keep in mind it's already Poisson. Find the probability that the shop sells a total of more than 30 cell phones in 6 randomly chosen weeks. So 6.1 into 6, that is for 6 weeks, and that is 36.6, that is the lambda. And now we will use normal approximation to Poisson. And what's the condition? Lambda is greater than 15. Make a habit of justifying it even before they have asked. So this is B part 1, part 2. First, let's look at this. That's the normal table that I have used. So now the new lambda is this much. Since lambda is greater than 15, W now follows a normal distribution. The mean and variance are the same. Already did, still I write it over here. And probability W is greater than 30. Make a habit of drawing a number line. So this is 30, this is 30.5, this is 29.5. 30 is not inclusive, so either choose 30.5 or either choose 29.5, which is the correct one, non-inclusive, therefore choose 30.5. From 30.5, subtract the mean divided by square root of variance, that's the z value. Z greater than a negative value, that's the same thing as z lesser than a positive value, that is direct reading. So this is 1.008, and this is the answer that you are getting. Now a separate part. Now it says that given that probability x is equals to 0 is 2 times probability y is equals to 1. So now these are weekly sales. They have not introduced the variable x and y. That was me introducing it. The lambda and mu are different. We just need an expression for them. Probability x is equals to 0, e raised to power of negative lambda, lambda raised to power of 0 factorial, power of 0 divided by 0 factorial, that is 1. Probability y is equals to 1, e raised to power of negative mu, mu raised to power of 1 over 1 factorial, and there is this 2 thing over here. So this 2 is there, that is this 2. This one is the red one, probability x is equals to 0. This is the blue one, probability y is equals to 1. Now they are asking lambda in terms of mu. So this is lambda, this is mu. They want lambda in terms of mu. So first of all, I wrote this down. Now how can I get these things down? By taking natural log of both sides. So take ln of both sides. Show everything. That is the keyword. So now even if it's very, very obvious, of course we know that ln was taken, but still write it down. What's the harm? So e raised to power of negative lambda ln e is 1. There are 2 things multiplying over here. You can even say there are 3 things, but I've taken 2u as one thing. That is 2u plus ln e raised to power of minus mu. Minus mu comes down. So now let's multiply with negative sign. This becomes positive, this becomes positive, this becomes negative. That is how this thing is written. So yes, this question, I think it was question number 3, that was long. 2 marks, 3 marks, that 5 marks, 5 plus 4 is 9, 9 plus 1 is 10, 10 plus 3 is 13 marks. That's a lot. Not difficult, but it was in one continuation. So when such long questions are there, usually they give 6 questions. If slightly shorter, they ask 7 questions. Now it says a firm sells cheese in packets. So there is no salt, it's unsalted, that it sells cheese in packets. The mass of cheese in these packets is normally distributed. That's the mean, that's the standard deviation. The firm makes a profit of $0.32 per kilogram. So that means whatever, if 1 kg is sold, so multiply it with 0.32. So this is the concept of multiplication. Find the probability total profit made on 50 randomly chosen packets is less than $18. For 50 packets, it's basically you are adding it for 50. So that is like addition. This is like multiplication. So now over here, let's look at the working. C is equals to 0.32 into M. M is the mass. So this is M is the mass of cheese and C is the cost. So now we have this information that expectation of the mass is 1.12 kg, standard deviation is 0.15, variance is 0.15 square. So expectation of C is expectation of 0.32 into m. 0.32 will come out and multiply, that is the value. Similarly, variance of 0.32 m, that is 0.32 square into variance of m. Multiply, that is this small value that you're getting. Now this T, that is for 50 separate packets. It's not 50 times, it's technically 50 separate packets. That's why I have not written 50C, I've written C1, C2, C3, all the way till C50. So now 50 times expectation of this value and 50 times variance of this value. So now this is 17.92 and 0.1152. I think there was another question like this in 2025 also. Do check it out. So now, yes, also one thing, that 2025 papers, I have done some, I'll be posting something of May, June, something of October, November. So stay tuned for these things. So now this is for S2 and naturally it would also be for P3 and maybe for M1 if some of your friends are there. So probability T is less than 18, 18 minus the mean divided by square root of variance, that is this value. Again, the normal distribution table was used and this is the answer that you're getting. So now this one was a short question, 6 marks altogether. Question number 5. It says Anita has a dice with side numbered 1, 2, 3, 4, 5, 6. The score on one throw is denoted by X. Assuming that the dice is fair, that means all the probabilities are equal. Show that variance of X is 35 over 12. So now X is the score on one throw. Then it says Anita suspects. Now another type 1, type 2 or hypothesis question. Anita suspects the dice is not fair. Now up till here you might think it's not equal to 1 over 6. She thinks that low scores are more likely to occur than high scores. She intends to throw the dice 50 times and if the mean score is less than 3, she will conclude that the dice is not fair. Now whenever we see a statement like this, if the mean score is less than 3, she will conclude the dice is not fair. This is the policy statement for type 1 error, for type 2 error. Remember this thing, type 1 is related with rejection region. Type 2 is related with acceptance region. She will conclude that dice is not fair. She will reject H0, that this is the rejection region, that the mean score is less than 3. That is the rejection region in terms of X bar. It is now given that the dice is not fair and expectation of X is 2.5. So a new mu was given. Assuming that variance of X still the same, calculate the probability of type 2 error. You may assume that the continuity correction is not required because we can say that CLT applies. That's why a continuity correction is not applicable over here. So now over here, what can we do? And then this thing, what is meant by type 2 error, the sample mean, why is it not possible? Those 1 markers will come at the end. Now, first of all, what I've done is that I have drawn a table, a DRV table, 1, 2, 3, 4, 5, 6. I calculated expectation, it's 3.5 and I have written over here obvious. Why is it obvious? Because this is like uniformly distributed. So the mean has to lie exactly in between because the probability is evenly distributed. So therefore the mean is 3.5. If someone can write it directly, perfectly fine. Expectation of X square, 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. So over here X square is multiplied with P. And I'm dividing once by 6, Y waste energy. Dividing once by 6, Y waste time. So that is 91 over 6, variance of X, expectation of X square minus expectation of X square. Have a good look, 91 over 6 minus 7 over 2 whole square. That's 49 over 4. 6 and 4, I multiplied, I wrote 24, that is 70 over 24. This comes out to be 35 over 12. So now, since the sample size is large, CLT applies. The mean should have been 3.5, but it's lesser. It's a normal distribution, variance is divided by 50. Reject H0 if mean is lesser than 3, that is the critical region. So for type 2 error, it should be opposite. It should be greater than or equal to 3. And you cannot use this value because what is the definition of type 2? except h naught when h naught is false, h1 is true. So h naught is false, we cannot use this one, we have to use a new value which the examiner will give. This is x bar minus mu sigma square over n under root, that is the z value. Z is greater than or equal to 2.070. 1 minus probability of z is lesser than or equal to this, that is the table value, and that is the final answer. I think I've pasted the table over here to show you the working. Now over here, what is meant by type 2 in the context of this question? Except h naught when h naught is false, h1 is true, mu is lesser than 3.5. There are more low scores possible, but we are accepting that everything is fair, accepting that the mean is still the same, so we are making a mistake. h1 is true, that is the reality, that is the perception, accepting that mean is still the same when in reality it has decreased. And now this is the number line, lesser than 3, that is the rejection region, greater than or equal to 3, that is the acceptance region. The mean score is 2.9, it lies in the rejection region, so how can type 2 occur? In order for type 2 to occur, it has to lie in the acceptance region. In order for type 1 to occur, it should lie in the rejection region, that is the simple truth. Now question number 6. It says the widths of the stone found on a certain beach are modeled by the probability distribution function or density function, that is k, that is ax minus x square, x lies between 0 and a. Where k and a are constants, show that this constant is 6 over a cube. Without calculation, give an expression for expectation of x in terms of a. Now let me do one thing, that is, if I draw a curve over here and this thing over here without even evaluating k, this is k, x common and a minus x. So now we know that this is a quadratic, coefficient of x square is negative. So what we can do is that, let me draw it like this, and this is the mid value over here. So this is 0, this is a, this is drawn between the roots. These two are the roots, because if this is equals to fx, if fx equals to 0, therefore x is 0, x is a. So this is a root, this is a root. Since this is a symmetric distribution, therefore expectation of x is the same thing as mean, that lies halfway between the roots. So 0 plus a, that is half of a. That is one way of doing it. And we know that 50% probability lies to the left, 50% probability lies to the right. So that is the knowledge over here, and this is halfway. Got the idea? So now this one, I gave the answer for this one. If they are asking for an expression, so expression can also be written like this, that is k, that is ax minus x square dx. In terms of integral, this one will be acceptable, but we can do it without integration. Keep that in mind. So the symmetry is always there in quadratic, in normal distribution, and in something like a uniform distribution, a horizontal line, because that would be equally divided. So now let's look at this. The first thing is that ax minus x square, integrate using the knowledge of P1. Plug in the upper limit. Now let me focus on the upper limit, that is a. So a square is there, that is a cube is there. If I plug in the 0, both terms will be 0. And then I also took this a cube common out. Half minus 1/3, that is 1/6. And therefore k comes out to be 6 over a cube. So that is the basic calculation. I have written this expression over here, that's the value of k inserted. And if they just want an expression, a value like this, then this is the right answer. So now over here, find the probability x less than 1/4 a, showing that this probability is independent of a, and use your answer to 6c part 1, that is this thing, 6c part 1. Find the probability x lies between 1/4 a and 3/4 a. So probability x is less than 1/4, that is the k value, ax minus x square. The integration was done earlier, Again, let's focus on these values. So this is 1/4 A. I'm plugging 1/4 A over here, squaring it, 1/4 A, cubing it, and I did not even bother showing for 0 because these two will become 0. So now this is what you're getting, and look on the inside. There is a cube, there is a cube, this a cube was taken common. There is already an a cube over here, that will cancel out. And then this is 1/32 minus 1/192. The LCM thing is done, and 5 into 6, that's 30/192. The variable disappears, therefore it's independent of A. And now the last part. Again, it's back to the sketch. It's a symmetric sketch. This is half A, that is the mean, that is the median. Lesser than 1/4 is 30/192. Greater than 3/4 is 30/192. Therefore, they are asking between 1/4 and 3/4. So these are these two values. So that is this value. So blue is used, I can use red. And I can use this thing over here, that is this greenish thing, that can be used. So in order to find these two things, that is add this, and subtract from 1. So add this, subtract from 1, and that's the answer. There is no need of simplifying it. And that completes this thing, S2. That is FEB March 2026, variant 62. Good luck for your exam. Stay tuned as more papers of P3, M1, S2, and in AS level P1 and S1 are coming up. Take care, everyone.